Okay, let's go. So pretty much, I'm gonna walk us through what we're gonna do today. Now, hang on. Let me get a learning goal. Learning goal. So we want to be able to understand always red rule in Manum, right? We want to be able to use it to update Mobjects, update functions, update a whole bunch of stuff, really. And we want to dream up of an animation that we want to be able to make, and then actually do it. So this is the plan, right? There's going to be no activities or any of that today. I just want to go through the process of how you'd actually build out an animation and the process that at least I do. And maybe you might say, that sucks, man. My way's better, and good for you. Tell me about it, right? But this is how I do it. So pretty much plan is that I want to show that if we've got the area of a circle, pi squared, then the derivative is 2 pi r. Now, if you know a little bit of differential calculus, you know that the 2 just comes down, right, using the power rule. But I want to kind of show it geometrically. So I want to have I want it to be nice and satisfying. So pretty much, like, I know that the rate at which the area is increasing or decreasing is equivalent to the perimeter, and so I want to be able to illustrate that out nicely, right? So pretty much this is what I want my Manum screen to look like. I want to have like a graph here where I've got like the y and x axis, and pretty much this is what I want to happen. I want to have some. Let me just check. I'm not dropping frames here. No, good. Okay, let's get back to it. So pretty much what I want to happen is I want to have like an axis. So I want to have this like graph here where this is y equals pi x squared if I was putting it as a lambda function, and I want that to happen. So it's that'll be like a parabola, and then I want there to be a slope, and on the slope I want to have slope equals and the value of the slope. So that's what I want the number to be, right? So like as the slope is moving along the curve, I want to know the value of the slope. I also want to have like a horizontal line there. I know, just a flex. Now here I want to have the area is equal to a particular number as well. So I want to have the value of the slope and I want to have the value of the area come out. Now while I'm doing that, I also want to have a circle mobject come out here where this is moving. So like if I've got, for example here, like at the point at this dot, if I've got like that is when x is equal to 1, then I want to have a circle with a radius of 1. And then as this goes to like x equals 2, I want to have a circle with a radius of 2. So pretty much what I want to happen is I want my circle to be updating with how my graph is going to be moving along. So there's actually quite a lot to consider when I'm updating here. So I want the slope to be updating, I want the circle to be updating, I want the numbers to be updating, I want the horizontal line to be updating. So there's a whole bunch of stuff, right? So really, oh no, that's the open-ended activity. So pretty much that's what I want to do. So let's code it. So let's go back to VS Code Studio. So we're going to import some stuff from Manum, and we're going to import NumPy, and we're going to get going, right? So I pretty much make a plane, which is just copy and paste from stuff that we did in the second tutorial, which is just, it's like a template of the plane that I want. And so as I'm doing this, I just want to have my slope come out there. Okay, anyway, so we'll get to that. We know what that is. I will just close that off, and I want to position it left to the 6, down times 3, because I want the origin to be left 6 and down times 3. So I'm going to move it further down there, just because I don't want to waste the space. I want there to be this this kind of a title there. So I'm going to do that. So let's get to that. So pretty much what I'm going to have here is I need to create my stuff. So I'm going to say, oh no, I've already got plane is equal to number plane. Moved it around. Very good. Now I'm going to add a value tracker here. So I'm going to say k is equal to value tracker. And we're going to start it at 0. And so this is pretty much tracking all my stuff. And I'm pretty much just going to define everything that I want on my scene. So I want a graph, and it's going to be plane.get graph. I want lambda, a lambda of x, such that it's going to be pi, so np.pi, times x times to the power of 2, so that's that, pi r squared, where r is x here, x minimum is equal to 0, and x maximum is equal to 2. And I want the color to be green. And just cause, right, I'm going to have a label here, so I'm going to say graph label is equal to math text. And I'm just going to say what I want it to be. So I want it to be area is equal to pi, which is backslash pi in latex, r to the power of 2. I want to set a width to this, so it's kind of like scaling, but I'm setting the width of it to 1. I want to put it next to the graph upright with a buff equal to 0.2. So I want it to be positioned, like I want that to be positioned up there, so I've got to add it to the scene. Now for the purposes of getting the number here, I'm just going to, and I might actually, for purposes of a slope value, and we'll see this why this is important later, deriv is equal to a plane dot get graph lambda x such that we've got 2 times np dot pi times x. So that's the circumference there. Okay, so I'm just going to define that as a function. I want a title, that's going to be text, which is area. Scale it down, so I could use scale or I could use set width. So I actually might use set width. 2. Okay, and like what I'm doing with set width here is I'm saying this has to have a width of 2 units along there. That's what set width means. So like this one, I've given it a set width of 1, so it's only going to go along 1 unit. Like this is 1 unit here. Anyway, oh, go away. So I want to set width, and I want to put it next to the plane, and I want it to go up from the plane. And I'm going to add an underline. So this is just an object to the title. Okay. Now, so pretty much I want to add some updating slopes here. So I'm not using graph scene, so I can't inherit from graph, like self.get secant slope group or any of that. So pretty much I'm just going to define my own stuff. So I'm going to say def get secant line, and it's going to input an x point, a plane that I want to get it to, just in case if I had multiple planes, and a graph. And what we're going to have here is we're going to have p1 is equal to plane input to graph point of x comma graph. P2 is equal to plane dot input to graph point, and we want this x plus 0.1. Okay, I could add a dx. No, I can't be asked. We could add a dx instead of saying 0.1, and we want that to go to the graph. We want the secant to be a line that goes from P1 to P2, and I could say color is equal to, and I might actually put this as an input here, so I can choose whatever color I want. That's the nice thing with defining your own stuff. And then I'm going to scale it, secant dot scale in place. And I want it 1.5 divided by secant dot get length, and I want to return the secant, which is just returning, that'll be returning this line here, which has been scaled right nicely. So I need a secant line. I also need a horizontal line, so def get horizontal line. Again, we're going to input an x, we're going to input a plane, we're going to input a graph, and we might as well input a color here. And so pretty much what we want to return is a dashed line which goes from plane dot towards to point. When x is 0, we have graph dot underlying function of x, comma, and then we've got plane coords to point of x, and then that underlying function. So that x point there as well. And we're gonna say color is equal to color. Right, now you can add more stuff to this. Like if you wanted to add a width, okay, you could just say stroke width is equal to width, and you could like have that as a parameter that you can include there, but I'm not going to. I mean, I probably should have kept it, but there you go. So that's gonna give us a horizontal line with a whole bunch of stuff we can change from there. And I also want to have a dot. Now I could actually include dot in here. Actually, I might do that. So I might say dot is equal to dot, and then move to plane, move to, and I'm actually just going to move the dot to P1, so wherever that value is there, and then here, actually, yeah, I am going to do this. I'm going to do this just to show here a little bit, and then I can say result is equal to a vector group, and then result dot add secant, comma, dot, and then return result. Okay, so that'll give that there. Now we're pretty much just going to add the Mobjects to the scene. So what we've coded so far here is we've got our horizontal line, we've got our slope line, we've created this graph, we've created that title, we've created that title, we've created that axis. So now we just need to create this circle here and like this stuff here with the updating values for the numbers, which are updating Mobjects. Not that, get rid of that, okay. So we're going to add them. So I'm going to say dot, or the coordinate point. Actually, no, I don't need to do that because I've redefined it how it is. So I'm going to say circle is equal to always red raw, because I want this to be updating. So lambda such that, and I'm going to say I've got a circle, and I want fill color is equal to green, fill opacity is equal to 0.75, stroke color is equal to red. I'm just creating this as I go. Stroke width is equal to 5. And this is the key part here. Okay, hang on, we're not in there yet. I want the radius to be equal to k.get value. So this right here is the part that's going to make our circle move out and in, because the k was our value tracker here. Right? That's what we're using to track all of our stuff. So as I change this value for k, it'll change the radius of the circle, so long as I put this always red raw in, because it's kind of like saying always update that circle accordingly. Now I'm going to add a radius to this, so it's equal to, and I'm going to say line, actually no, I want always red raw, because I want this to be always updating, lambda, such that, and now it's going to be a line that goes from circle dot get center, and it's going to end up at circle dot get top. So pretty much I just want a line that goes from like there, that goes from like here to here. Okay, and I want that stroke color to be equal to red. Okay, so I've created my radius there, and I'm going to add the r text is equal to math text, and just r, set width to be 0.5, like just make it really small, and put it next to the radius. Now again, I could add always red raw to this to make it constantly updating, but I really can't bother for the time being. I might actually, because you can also define them using updaters, so you can actually go r_text.add updater and then use this method as well. So you can say it's lambda x next to, and I want it to be next to the radius all the time. Okay, so I might add an updater like this. Okay. Now that's pretty much, I've defined my updaters for my circle here. So pretty much as the value of k changes, this will move like up and like, you know, the circle will be constantly changing, which is kind of cool. Now I want to add this stuff down here. So I want to add this finer detailed stuff here where the slope value, I want it to spit out a number, and then the area value, I want it to spit out a number. So let's get to, oh, hey, back there, thank you. Alright, so now this is for the bottom stuff. So I'm just going to call it area text. So I'm just going to make it kind of small, and I'm going to shift it down times 2 plus right. So I pretty much just want to shift it kind of like, yeah, like down 2, so I want it to be like here, and then to the right 1. It's like just going off the unit. This is why I like this little screenshot here, because it kind of helps position everything nicely. Okay, so I'll do that there. I'll keep that there. And now I want the value, area underscore val is equal to, and I want it to be decimal number, number of decimal places is equal to, I'll say 3, okay, and I want to scale it 0.7 next to my area text to the right of it. Okay, now I'm going to add an updater here. So area val is equal dot add updater, and I can go lambda x such that x is setting the value to, and this is why. Oh no, hang on. It'll just be graph dot underlying function, which is k dot get value. Okay, so quite a bit to talk over here. Pretty much, so I'm saying this is going to be a decimal number that tells me the value of the area. But I know that, not a Word document, I know that the value of the area is given by this function here. So close the Word document. So I want that tracked by k, because k is the value of the radius, which is in the Mobject here, which will be the same value along here. So as this value here is changing along there, so as we're going along here, this will be getting bigger and bigger and bigger, and it'll tell me the exact number given by wherever I am along in my y-axis there. Okay, so that's pretty awesome. Right. So that's kind of nice. Now I've got a little bit more to do. I've got to do the perimeter stuff. So perim text is equal to, I'm going to hit text, and I want this to be my I must have changed this a little bit on how I was planning it out. Okay, anyway, let's just assume that I want to create this here. This isn't what I've got coded, so that's going to be kind of annoying. So let's say I want to create this here. So slope is equal to some number, and I want it to stay next to the slope. Okay, well, let's see if we can get this right on the fly. So pretty much what I'm going to do is I'm going to call it slope text, and that's going to be equal to text of slope, right? Or slope equals, I should say. Let's scale it down 0.7, and let's put it next to, what did we call the slope? We haven't even defined our slopes yet. Hang on. Where is it here then? Where the hell is it gone? Okay. Secant. Let's add the secant, and I want this to be updating, so it's always red raw lambda such that, and I want to get secant slope. That is what I've defined up here. Oh no, get secant line. Sorry, not get secant slope. I want x to be equal to k dot get value. I want my plane to be equal to the plane that I've created, the graph to be equal to the graph that I've created, or whatever function it is, and I want the color to be equal to yellow. Okay, so that'll always update because I've added always red raw to it, and I need to do the same for my horizontal line. So horizontal line is equal to again always red raw of lambda such that, and we're going to go get horizontal line. So that's what I've created here. It's going to input x dot get k dot get value, plane is equal to plane, graph is equal to graph, and the color is equal to, let's make this one orange so we can kind of see the distinction between them. Okay, so now that I've defined that stuff, I can actually put this next to what I've created, which is the secant. I want it to stay to the right. I want it to have a buffer of 0.2. And instead of adding an updater, I can, because this is just a Mobject, I can add always red raw lambda such that, and then create it and make sure I've closed off my parentheses properly. I'm going to do the same thing for my slope value, just to show like you can do it this way or you can do it this way, and they should both work. Is equal to always, so it's always red raw is like we're always constantly updating it. So lambda such that, and we're going to have a decimal number, oh, not an underscore there, number, which has a number of decimal places equal to, let's say 2. I want to scale it to 0.7. I want to set the color to purple, and I want to set the value, and this set value is within the always red raw updating thing. So I want to set it to be, now what is the value of the perimeter going to be? It's going to be the value of the derivative. So I'm going to set it to deriv in brackets k dot get value. I'm pretty sure that's the correct way to call that. Let me check and see if I've... no, deriv dot underlying. I might actually enter this down. Deriv dot underlying function, because I want it to be the y value of the derivative, of course. Okay, so that pretty much should be everything. So now I'm just going to start playing some stuff. So self-play, lagged start of, and here we're going to have, we're going to write the plane, we're going to write the title, we're going to show the creation of the underline. So this is all the stuff I made at the very beginning here. So we're going to show the title, the underline, and the plane, which will settle that stuff out there. I'm going to show oh, hang on, I need to close my bracket off. Show creation of the graph, write the graph label, and I want this to have a runtime of 5 with a lag ratio of 0.5, something like that. Okay, then we're going to wait. So pretty much we would have added the title, the plane, the graph label, the underline there. Then I'm going to self.add the circle. I'm going to add the area text. I'm going to add the area value. I'm going to add the slope text. I'm going to add the slope value. I'm going to add the, I've just called it val. I'm going to add my radius. I'm going to add my secant. I'm I'm going to add I'm just pretty much just adding everything here. I'm going to add my horizontal line. I'm going to add my R text. So we've got area text, area value, slope text, yeah, slope value, radius, cool, circle. Okay, so that'll pretty much just be everything. So I'm just adding everything to the scene. And now I'm going to say self play k.animate.set value equal to 2 with a run time of, let's go 12 so we can see it nice and slow. And then we go self wait, and then we might actually play it back a little bit. So self play and k.animate.set value to be 1, and then I want the run time to be let's go 5, just so play it back a bit short there. All right, we might get an error here because we've just done like 100 lines of code. Hopefully we do, so we can like get comfortable with the error and see and actually practice fixing it up, because that's always a nice thing to do. So we're going to run it there. Alright, so I am anticipating an error. Like I'd imagine I have screwed up somewhere. Have we dropped many frames? Couple. It's all good. So this is running. No, of course it doesn't have any errors. Friggin' awesome, man. It's a joke. So we just let it run, let it render. No, there's no errors because I have this pre-prepared for the most part. And it's going to take ages because my computer's like just slow for some reason. Very slow. Holy dooly, what the hell? Actually this long. What a joke. No, hang on. Okay, so we know it's going to run properly. Let me just... Instead of 12 seconds, you're just going to have to live with it. We'll go 4 seconds and then 2 seconds. And I'm going to run it in low quality. But you can run it in whatever quality you want. Yeah. Took my computer to work today, that's probably why. Like it's not on 100%. So it's still charging. Come on, champ. Let's get going. I guess it is doing quite a fair bit of animating on the screen if we consider it. But chop chop. Come on. Shit to do. Okay, so cool, so there's the graph area, very cool. There's that thing there. Ah, ha. Okay, so there's always there will always be something wrong, mate. You're never gonna get it perfect. Okay, so I noticed a couple things. This value here, I should be putting it next to there, and this R should not be that huge. So let's actually fix that up. So this, I forgot to put it next to slope text, and this R text like make it tiny. Yeah. And just to highlight, like, you can use always red raw if you want, or you can use add updater, like, interchangeably. I just like always red raw because you don't have to write many lines of code and it just automatically updates everything as is. Like, it's actually quite nice. Yeah, and defining this stuff here, like, you can add stuff to this, you can not add stuff to it, it's fine. If you had multiple planes, you'd be able to put different stuff in there. Okay, anyway, now that I fixed that up, I actually want to see if it looks a little better. Okay, again, like, mine's just rendering hyper slow for whatever reason. But like this, to be honest, like we're actually getting quite complex with this sort of animation. Like if you're able to understand what's going on here, you're pretty good. Like there's a lot of updaters. There's a fair bit of pre-planning going in. But that's really the extent. Like really with this understanding. Oh, and for loops. If you kind of wrap your head around for loops, using them within Manim, that's it. You can make some cool shit. Okay, so this should be fixed up. Yeah, so there's the function. Cool. Tells us the value of the area. This slope value is telling us the value of the perimeter, not the value of the area. And you can kind of do a gut check here. Hang on, let's get to the maximum value here. So this is when r is equal to 2, right? And so if you do pi r squared, that's like doing pi times r squared is 2 squared is 4. So the area of in there is 4 pi, which is 12.57. And the perimeter is 2 pi r, so it's 2 times pi times r, which is 2, which should be the same value. So like this slope in this area, it checks out. That's all I'm trying to say. And you know, you can animate this as you want, but if you've got things nicely laid out, you can show that, yeah, like, you know, therefore we can see that the rate of change of the circle, blah 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 blah. You can go nuts, right? You know, if you've got it nicely, and you can just rewind it and play it as many times as you need until whoever you're trying to show or the student is like, oh, sir, I freaking get it, and you're like, cool, happy days. Probably could make it a little bit better by just shifting this. Okay, so I could go shift right plus up, so just shifting it more out of the way. I could flex a little here and add like a sheen factor. So sheen factor is equal to, I don't know, 1. See what that looks like. But that's pretty much it. So like I don't have any activities. I just pretty much, I want to see, I mean, if you've made it up to this point, you're even listening, I reckon it'd be cool to see like, if you've got, okay, like I've got my own animation in mind, I've got to update a whole bunch of stuff, just like create it and share it. Because, I mean, I don't know about other people, but I froth it. Like I actually think it's pretty sick seeing people learn from one another and then, you know, share the cool things and, you know, take a bit of pride in the stuff that they're making. I think I froth that from all of the orifices, including the penis. Anyway. So this, I mean, the only thing I've done here is just shifted the circle and added a sheen factor. So like if I want the circle to look a little different or a little fancier. Yeah, which it does there. Yeah, we can see, you know, kind of adds that lighting effect. Anyway, that's me. I got nothing more to say. So if you got some cool stuff to share, please do. I'd actually quite like seeing it.